Good evening, everyone. Uh, are you able to hear me? Hello, am I audible? Are you able to hear me, guys? Okay, so let us start this week's session. Uh, I welcome you all back to the third week for in the digital electronic circuit live session. And today we will do some questions that can help you with the assignments and also with your exam. So let us start. So the first question that we have for today is identify the number of prime implicants and essential prime implicants for the function f, a, b, c, d given with these main terms. So before going to what are prime and essential prime implicants, I hope you know from the video, but I'll cover it again. But first, I want you to draw the K-map for this. Then we will identify the prime implicants and essential prime implicants easily. So I suggest you can draw with me. So what we have is B, C, D equals. So it is a four variable function. So let us make a four variable K-map. So let A bar, B bar, B, B, A, B bar. Sorry. So I hope by this time you are familiar how to make a K-map. If not, uh, please look at it and how we number it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay. So now wherever these numbers lie, we'll put 1, right? So 0, 1, 4, 6, 7, 8, 10, 14, 15. Okay. So now we can form the groups the way we want now, but uh, what are prime implicants? So prime implicants means the maximum groups that we can form, maximum possible. And essential prime implicants groups that have at least a single one which is not shared by any other group. So these are prime implicants and essential prime implicants. Okay, so let us see what these are in, with this example first. Okay, so what are the groups? What are all possible groups? So here, write this possible. To see it, look at all the possible groups that we can form here. So let us try to make groups. So one group can be this, right? So let me call it one. Another group, two, three, four, five. Now, if you see, let me take another color. We can form one more group here also, like this and this. This is six. We can form another group here. Oh, that is already formed. Sorry. Uh, we can form one more group here. Seven. Maybe not this one. This is already covered. Not too far. Form another group here. Yeah. Seven. So here we have total seven prime implicants. Here. And those PIs are, can you help me write them? Like, please write in the chat all the literals that will be, all the SOP form literals that will be there. So we start from group one. So what is group one? This is group one, right? That is A bar, C bar. A bar, sorry. A bar, C bar, D bar. Yes. C bar, D bar plus group two. A bar, B bar, C bar plus group three is what? The squad. So what? B, C, right? Plus what is number four? This is what? A, C, D bar. Three more, right? So number five is what? Number five. This and this. This is what? D bar, A, B bar, D bar. Plus number six. Six is this. Is what? B bar, C bar, D bar. And one more. Last one is this. A bar, B, D bar. So these are the seven PIs that we have. Now let's look at EPIs. So Venkataraman says three EPIs. We have only, let me check. Um, we have two EPIs only, right? So if you see here, these two ones are not there in any other group except this group, right? And this one. is not there in any group except this group. So we have only two APIs. Two that are A bar, B bar, C bar plus nothing BC. Is it clear? This one is only there in this group number 2 only, and these two ones are there only in this group number 3. Rest all the ones are used multiple times. If you look at the definition, API is groups that have at least a single one which is not shared by any other group. So group 2 has a single one that is not shared by other group, and group 3 has these two ones which are not shared by any other group. So that's why we have two APIs. Is it clear? Please feel free to use your mic also if you wish to. Venkataraman, is it clear? You said 3. Do you want me to repeat it? Please say yes or no so we can move ahead, or I'll repeat it. It's clear. Okay. Fine then. Let's go to the next question. Okay. So next question is for 5 variable K-map. Okay, so yeah. So I'll draw with you, but I'd like you to give me an answer also. So I'll solve this one. So I have two questions on 5 variable K-map. I'll solve the first one. You guys solve the second one. Okay. So how to make a 5 variable K-map? So it is simple. So we know how to make a 4 variable K-map, right? We just made this 4 variable K-map. Let's say they introduce another variable E here. So what we can do is we can make two 4 variable K-map. One would represent E, other would represent E bar. Simple, right? So let us try to do that. So let us make two K-maps first. So what I'll do is I'll just make another copy of this now. So let this be for equal to 0, let this be for equal to 1. Sorry. Okay. So how we number it? So this is for, so what we have a number system is like this: A, B, C, D, E. right? So what would be 0, 0, 0, 0, 0, 0, right? And if I take here A, B, C, D, E, 1, 0, 0, 0, 0, that would be what? 16. So here numbering would be like 16, here it will be 0. It will be similar to previous 1, 0, 1, 3, 2, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, here 16, 17, 18, 19, 20, 21, 22, 23, 4, 25, 26, 27, 28, 29, 30, 31. Okay, so now let us fill the numbers, ones that we have. We have 0, 2, 8, 10, 0, let me take a break, 0, 2, 8, 10, and this 11, 14, 11, 13, 16, 18, 11, 13, 16, 18, 24, 26, 29, 24, 26, 29. Okay, and we also have 5, 6, 9, 14. You don't care. 5, 6, 9, 14, 21, 22, 30. 21, 22, 30. Okay. Now let us make pairs. So in five variable K-map, we can make. Okay, stop. So nobody told me I messed this up. 3, 2. Okay. So in this five variable K-map, we can form these all 8 corners. This, this, and this, and this. They form one octet. So this is, what is this? I can call it. So it will be C bar and E bar. C bar, E bar. Right. So why I'm calling, how I can uh, combine all these 8 from, just from, if we forget about this K-map, just from this K-map, what I will get, this will be A, A, A bar, sorry, since it is always, everything contains A bar, C bar, E. This will give me A, C bar, E bar, sorry, E bar. So both combined will give me C bar, E bar, A plus A bar, that is just C bar, E bar. That is how I'm able to group all these 8 ones together, right? So one, we have the C bar, E bar. Next pair, we can have this, that is, we have the same here also. So these two and these two can be paired. We take different color. These two and these two, they are a pair. So this would be what? C, B bar, E bar. And another that would be, we would have is So this whole not possible. Sorry, this is not working. It's to be this right. That is now it is not common in both, right? Not common. So we will have to take on a bar in as a little a bar, b c bar. So finally, what we get is f equals to what we had. These right, c bar e bar, c bar d and this. So we have two a bar b c bar plus c bar e bar plus c d bar e bar. So is it clear? So the only thing that you need to take care of that uh, if two groups are being formed at the same position, they can be combined because both will give you this will give you something. Let's say this gave me C D bar E into A bar. This will give me C D bar E into A. If I take common, I'll get C D bar E only. Right? Similar thing with that we did here. But here in this term, since this part was not common and here, so we could not take it. That's why we had to consider A bar. So and this is the answer. Okay. Is this clear? Is there any doubt in this question? Okay, great. So uh, this is an easier one. Please, somebody do this and tell me the answer. I won't solve this one. So I'll wait around 5 minutes for the answer. It is relatively easier. Just note the literals. And then I'll show the previous K map if you want to see the numbering. Draw the K map. So numbering goes like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 20, 26, 27, 28, 29, 30, 31. Okay. This is for A bar, this is for A. Please let me know the answer for this one. Has anyone solved it? Let me see who all are attending. Guys, are you able to do this question? Yuvarani, Shankare, and Nan Nandanavam, Nandanavanam, sorry, and Jagannath, Gauri, Bhuvneshwari. Ashwini has already said yes, and Pureddy. So out of I think 8 participants are here, but only 3 are listening to me. Okay. If you guys are able to solve this, please let me know the answer that you are getting. Please type in the chat or speak up, or if you want to share your screen, whatever works for you. If you want me to solve it, then also please you can mention I'll solve it. Okay. So I'll also start solving it with you. So if meanwhile somebody gets the answer, please write it in chat. But let us try to solve it together. Okay. So okay, Ashwini has written. Let me check. Okay, let us check. Let us solve it and then we will write it together. Okay. So first step is I've made these K-maps. Now with these literals, I'll just fill in ones wherever these numbers lie, right? So I have one at 0, 5, 6, 8, 9, 10, 11, 16, 20, 24, 25, 26, 27. Okay, great. Now the groups that we can form are, this is a group, uh, this is also a group. Wait, one second. And this is a group, and this is a group, and these two are alone. Takes another color. This is separate, and this is okay. So this is separate. Okay. Yellow blue plus blue. So I'll just use the respective colors. Let's say for yellow. Let's see, brighter yellow. Is it visible? Okay, it's visible. So we have B bar, sorry, C bar, D bar, E bar is one. Okay, and another that we have is from the green one. It's green plus B C bar. Then let us take this pink one. This pink one is B. Sorry, now we'll have A, B bar, D bar, E bar. Then blue one is A bar, B bar, C, D, E bar. And this brown one is B bar, C, sorry, A bar, B bar, C, D bar, E. Okay, so let us see what you are getting. You're getting B, C bar, correct. So let us just, I'll just match with what Ashmi is getting. Uh, B, C bar is here, B bar, C bar, D bar, E. Okay, this would also work C bar, D bar, E itself. No need of B bar because you see these four will form the same group, right? C bar, D bar, E bar. It's not necessary, but it's fine. We can reduce one variable. Another thing is A bar, B bar, C, D bar, E. And A bar, B bar, C, D bar, E is this. Okay. Then A bar, B bar, C, D, E bar. A bar, B bar, C, D, E bar is there. A, B bar, D bar, E bar. This is also here. Okay. So yours, Ashwini, yours is also correct. It's not wrong. So yeah. Okay. So those who are unable to solve it, please try it. You all have written same answers. Yeah, but nobody has written like this one. This one like me. Okay. Anyways, it's good to see that you are able to solve this. So let us move on to the next question. So the next question is find the total cost using multiple output minimization method. Okay. So let us see this question. Okay. So I'll give the concepts for this, but currently what we see is we have two functions, right? F1 and F2. So step one is draw K map for both. So let's start with drawing K map. So I just paste my previous K map. need to change the labels. Okay, so four variable function a bar b bar a bar b a b a b bar c bar d bar c bar d c d c d bar b bar a bar. Okay, leave it. So yeah, this is one not required. 1, 3, 2, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. I'll just copy this now. Okay, great. Okay, so let us make this one for function 1. In function 1, we have, let me rewrite the functions. F1 equals to sigma n 0, 1, 10, 13, 14 plus sigma d 4, 5, 12, right? F2 is equals to sigma n 5, 8, 9, 10, 13 plus sigma d 6, 14. So let us make this one for function 1, this one for function 2. Okay, so we have 0, 1, 10, 13, 14, and don't get it, 4, 5, 12. Okay, next for this, let us use some other color. Yeah, 5, 8, 9, 10, 13, 6, and 14. Okay, so okay. So now if I were to make K-map regularly, how would I make it? I'll make this as a quad and this as a quad and this, right? So what I would get, so let us first make that only. Make, okay. This I'll make, this I'll make, and this I'll make. So for F1, I would get, what is this? A bar C bar plus B C bar plus A C D bar. For F2, how I would make is, for F2, I would make this, and this only. Wait, for F2, I would have A B bar, sorry, A B bar C bar plus B C bar D plus A C D bar. Okay, so I hope there is no problem till here. Anyways, but the point is, what we have to do is we have to do multiple output minimization. Currently, we have done single function minimization, but what we are trying to achieve is we want to minimize uh, number of gates for both the for gates for implementation of both the circuits to, sorry, both the functions together. This is what we want to achieve, right? So again, we will, what we will do, we will look at the literal we will try to make, to achieve this, we will try to make common groups. Common groups in both functions. Right. So how, what we can do instead of making this, so there is no possibility of any other group in F2, right? But in F1, we can make common groups, like this group can be made common and this group can be made common, right? The third group we can make is this only. Okay. So, so let's try to make it like this. So instead of writing F1 as this, I can write F1. Sorry, F1 equals to A bar, B bar, C bar plus A, B bar, B, C bar, D plus A, C, D bar. Right. So now if you see, these two terms are common in both, right? So now if I had to implement both these functions together, let's say I wanted to get an output of both of them together, then I would just I would just need to implement this part only once, and then I can reuse it for the second part, right? So let's say, suppose what I'm trying to say is, let's say want to make some circuit giving A, B, C, D as inputs. I want to get both F1 and F2 as output, right? So logically, what we would do, we will just use some gates and implement the function for both. But since these terms are common for both, this circuit we will make only once. So that is why we have done this. We have taken the common literals as the groups. So common are this and this only, and this, right? So I hope I'm making sense, but if not, please let me know. I'll repeat. So anyways, so now we are being asked to find what uh, total cost. Okay, total cost is what we are asked to find. So for total cost, first we need to know something, that is the number of gates or gate cost. Okay, so for that, what we need to do is gate cost will be, okay, it is the number of total number of literals, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, plus the number of functions 10, sorry, number of terms 10, 11, and 12. So this would give me G equals to 12. Okay, let me repeat, it is G is what? Number of literals plus number of terms. Number of literals are 12, right? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9, sorry, 9 literals and 3 terms. 1, 2, 3, 3 terms. Total 12. But 12 is for F1 only, right? Yeah, you are right. Similarly, we'll count for F2. So, but we know for F2 now this part has already been repeated, right? We won't count the same, uh, we won't count the literals here. We will just count the number of terms. So it will be 1, 2, 3, 4, 5, 6. Since this part has already been repeated here, we won't repeat the same literals. We'll just take the terms. So it will be plus 6 for F2. Total we have 18. G is 18 and total cost is G plus number of uh, gates required. So G is 18. So number of gates required for implementing this is one gate for this, second gate for this, third gate for this, and a fourth gate for all four gates from here. here we already have this output. We just need one gate for this and another gate for OR of this, right? So 2 from here and 4 from here. 15 plus 2 plus 4. This is 2 plus 4. This gives us what? 24. So again, I'll repeat what is number of gates. So what we had here, number of gates is, so to make A bar, B bar, C. So assuming that I have the complemented terms as input, A bar is also available. So to make this term A bar, B bar, C bar, what I need a 3 input, let's say AND gate, right? A bar, B bar, C bar. So this is one gate from this term. Similarly, second term will give me one AND gate, third term will give me one AND gate, and one 3 input OR gate for combining these three. So that is total 4 gates for this, right? Now for the second function, we already have this. We have already made this for getting F1, right? Now we will reuse this circuit. We just need one AND gate here and one OR gate here, and we will reuse this part to make this. So it is 2 plus 4 is 24. Total 18 plus 24. So this is the total cost, which was actually asked in the question. So it might be a new concept if you have not seen the videos. So let me know if you want me to repeat this or if we can continue. Okay, I'll repeat it. So I hope this part is clear. So what we did first, we were given two functions, F1 and F2, right? And we are being asked that multiple output optimization. That is, we want to implement both of them together in a circuit, right? So we want to make minimum. Sorry, we want to make circuit with minimum gates that can implement both F1 and F2 together, right? And the only solution to do that is if we have to find common sub-circuits between F1 and F2, right? So how did we do that? We did that with K-map. So we made K-map for both F1 and F2. In general, we would have formed groups like this for this and this, right? But since we see in F2, we have the only possibility of groups are like this. And these groups can be common here, right? So this is what I have written, right? B C bar D and B C bar D here can be common. A C D bar, A C D bar is this, and A C D bar, these both can be common. So by doing this, what did I do? I will just need to make this part of the circuit once, only once, right? I can reuse it for both F1 and F2. That is what we were doing here. Okay. So, okay, yeah, that was we were doing. We're making some circuits inside that and which we wanted to reuse so that we can both realize both F1 and F2. So I hope now this is clear how I've written this expression and this expression. I've just taken these groups for F1 and these groups for F2. Just I'm trying to uh, maximize the common groups. These two are the common groups between both. Okay. Now they have asked what is the total cost. Okay. So for total cost is given by TC equals to G plus number of gates. Here, what is G? G is number of literals plus number of terms. Okay, so number of literals means how many number of uh, alphabets that we have here, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. That is, we have 9 literals here. And number of terms in F1 we have 1 term, 2 term, and 3 term. We have 3 terms. So 9 plus 3 is 12 for F1. For F2, 1, 2, 3. These 3 terms are there, but these are all old terms, so I won't count them again. But I'll have to add them, right? So for that one term, sorry, 1, 2, 3 is there, but the number of terms will be 3 only. 1, 2, 3. Letters will be 3. So for F2, number of letters is equals to 3. Number of terms equals to 3. So that is how we got 6. We are using this, so we won't count number of literals. We'll take only 1, 2, 3. But the number of terms are 3. 1, 2, and 3. Okay. That is how we got 6. Total is 18. Now I told TC is what? Total cost is G plus number of gates. So what I'm saying is to make this A bar, B bar, C bar, right? What I would need is A bar, B bar, C bar. Output is A bar, B bar, C bar. That is one AND gate. So one gate for this. Similarly, one gate for this. And similarly, another gate for this. Okay. And at the end, one OR gate. One 3 input OR gate for all these three terms A bar, B bar, C bar, B, C bar, D, and A, C, D bar. Right. So total 4 gates for F. Sorry, total 4 gates for F1. Okay. And for F2, what we will have, this part is repeated. I will need one AND gate for this and one OR gate for adding this whole thing. So 2 gates total. 4 gates from here, 2 gates from here, total 6 gates. Sorry, yeah, total 6 gates. And in total cost is 24.
शिविटारी डब्बा कुठला मध्ये टाकलं
Okay. So if you see what we have achieved with this, so what was the purpose and what we did. So let's say what we have, it is implemented. Okay. A bar, B bar, C bar, B, C bar, D, A, C, D bar. One more thing is A, B bar, C bar. Now, end of these three, give me F1 and also end of these three, give me F2. Right. So what we achieved here is we just took this part of the circuit as common to realize both F1 and F2. That is the simple thing that we did here. Okay. So if this is clear, should we move ahead? Please let me know if something is still not clear, else we will go forward. Okay, so let us move on to the next question. For the following expression, specify the type of hazard that may be susceptible to. Okay, so hazards, we have three types of hazards that are three written here only: static zero, static one, and dynamic hazard. Okay, so if you see what is static zero hazard, uh, let me just read through it. And let x equal to 1, right? So it will be 1 here, it will be 0 here. I'll get y equal to 1. But let's say all gates have tau pd equals to tau. Okay. Now let's say at t equal to 0, I changed x from 1 to 0. So I made this 0. But this will go from, so here it is going 1 to 0, but this will go from 0 to 1 after tau seconds, right? So if I make some waveforms, let's say this is x. So I will say that t equal to 0. So y, what will y experience? Okay. Let's not talk about y first. Let's talk about, let me call this node as y1. So what y1 will see after a delay of tau seconds, it will get, sorry, it is not. After a delay of tau second, it will go from 0 to 1, right? Now what y will experience? Y ideally, if there was no delay, right, it would always remain 1. But here what is happening in this period of time, in this period of time we have x equal to 0 and y1 equal to 0. That's why we will have y equal to 0 after delay, of course. So y will take its own delay tau again, go to 0, then again after tau it will become 1. So ideally it should have stayed 1 always like this if there was no tau, if tau equal to 0. But due to this switch from 1 to 0 of x, there is a glitch here that we did not want. This is called static, what is it? Hazard. Okay. Similar thing happens in case we have an AND gate. So let's say again x. Earlier it was, let's say, 0. So y was 0, right? But it goes from 0 to 1. So this will take some time to go from 1 to 0, right? So at some time they both will be 1. So x, if I draw a 0 at time t equal to 0, it went from 0 to 1. So if this is y1, y1 will go from 1 to 0 after some time tau, and y will give me slightly for this time tau, then 0. Okay, so this is static 0 hazard. It should have remained always 1, sorry, always 0, but it became 1 for a very brief moment. static zero hazard. Now, in dynamic hazard, it will be like the circuit will be more complex. We will have more OR gates, something like that. But we'll have multiple shifts, unwanted shifts. If it had to remain zero, it will be there will be multiple shifts. That is called dynamic hazard. Okay. So now, okay. So now the condition for when we get static hazard is, you see, this is an OR gate, right? So condition is x plus x bar equals to 1. This is static 1. Yeah, static 1 hazard. Static 0 condition is x dot x bar equals to 0. This is the condition for static 0 hazard. And for dynamic hazard, we get the combination of these x bar plus x for dynamic. Okay, so now in this question, what we have, let me go back. Okay, we have a c bar, a plus c bar, b plus d, c d. Okay, if a equal to 1 and b, sorry, if a equal uh, to 0 and b equal to 1 and d equal to 1, what we will have? A is 0, b is 1, d is 1. We will have c bar plus c. That will give me static 0 hazard. Sorry, static 1. If, choose another color, if let's say um, a is 0, b is 0 and d is also 0. Okay, then we will get c bar into c, that is static 0 hazard. And for dynamic hazard, I told what? Uh, this color. Okay, I wrote here what? 0, b is 0, d is 0. For dynamic, if we have a is 0, b is 0, d is 1, then we will have c bar c plus c. This is dynamic hazard. Yeah, this is the condition for dynamic hazard. C bar C plus C. So yeah, so don't go by like it is 0 or 1. It's just when will this condition occur, there will be a hazard. Don't go to 0 or 1. Yeah. So in this expression, we have all three of them: static 0, static 1, and dynamic. So I think it is given in. If you are still have doubts, please visit the two videos in I think week 3 lectures. It is explained very well. But if you have any doubt here currently, please let me know. These are actually the three conditions: static 1 hazard, static 0 hazard, and dynamic hazard. In this circuit, we have all three in this expression. Sorry. Okay, I'll repeat the waveform for static 1 and 0. So this is static 1. Okay, so fine. Where is this? So we just have this circuit, right, initially. Okay, and we are giving, so ideally, if you see, this is an OR gate, right? So for OR gate, if any of the inputs is 1, if either this is 1 or this is 1, output will be 1. So if I give even x equal to 0, this will become 1 and output will always remain 1. So output should always remain 1, right? That is why it is called static 1. It's always 1. But it is a hazard, that means there is something wrong. It will not always remain 1. That is due to its propagation delay. So let's say this gate has a propagation delay of tau. Also, this gate has a propagation delay of tau. So what I'm doing is, let's say at time t equal to, sorry, time t equal to 0, I'm changing from x equal to 1. X was 1, right? Earlier I am changing it to 0. So if it was 1, I'm changing it to 0. So it was 1 here also. It will change to 0 at t equal to 0. But at this gate has a propagation delay of tau. So at t equal to tau, this 0 will go to 1, right? At t equal to tau. So is so let me draw this. T equal to 0, we had this. X was going from 0, 1 to 0 at t equal to tau. So this is t equal to tau. Y1 will go from to what? This is Y1. This node is Y1. Okay. Now, uh, okay. So now at here, what happens is our OR gate also has a propagation delay of tau, right? So this is 1 and this is 0. So it will be 1. Okay, it will be 1. But here, what it sees that both the inputs are 0, 0 and 0. So ideally, it should go 0, right? But since this also has a propagation delay of tau, it will go to 0 after some delay. After this delay of tau, it will go to 0. So it goes to 0, but after a delay of tau. Now we see, so till here we have covered, right? Here both were 0, 0, so we have gotten 0. Now after this time interval tau, it goes to 1 again. So it will be delayed again here by tau. So this is tau. So at time equal to t equal to 2 tau, it will again go to 1. So that is, so what I said is it had to remain static at 1, but it became 0 for a brief moment. This is the hazard. Similarly, in for static 0 case, so this is an AND gate, right? So if any of the inputs is 0, output will be 0. So it should be remain static at 0. But at time here, I did the same thing. At t equal to 0 time, we are changing this from 0 to 1. But there is a delay here. So at t equal to tau time, this will go from 1 to 0. This output of this NOT gate will go from 1 to 0. So here at t equal to tau, K equal to tau. Output of this NOT gate goes from 1 to 0. Now, since this is an AND gate, right? It sees that in this period of time, what these both are inputs to AND gates, right? So it sees that in this period of time, both the inputs are 1. So output should be y equal to 1. But since it also has a delay of tau, so after a delay, so here ideally if it had no delay, if the tau was 0, it would have gone 1 right here. Then 1 1 should have given 1, right? But since it has the delay, it will go 1 after a delay of tau. Then after a delay of tau, it will go back to 0. That is how we are getting this waveform. Ideally, it should have been 0 always, that is static 0, but we have a hazard. Is this clear now, Bhuvneshwari? Yes. Okay. So this is just the condition that I have here. If this is x, this is x bar. So x, wherever we have this x and x bar, we will have a this static 0 uh, hazard. Wherever we have this AND gate, that is x plus x bar, we have static 1 uh, hazard. And a combination of both, that is x bar x plus x, is dynamic. In dynamic, it is like static 1, then static 0, static 1, static 0 repeats multiple times. So how do you identify the hazard is just that. Look at the expression, find out the condition of A, B, and D, wherever we can make something. So here we see that complement forms are only with C. C bar and C is only available. So this is the only variable that can cause a hazard. So we just need to look for the conditions for A, B, and other variables that can give us the hazard cases. So C plus C bar is static 1. That can come when if A is 0, B is 1, D is 1. And similarly, C bar C will be static 0. It will come with A0, B0, and D0. And similarly for this. Okay, so let us look at the next questions. I'll solve two more important questions today. Okay. Okay. So, what kind of hazard occurs? Measure the hazard-free implementation of given functions. So how do we fix these hazards, right? So to fix these hazards, what we do is, okay, let me tell you. A plus C bar. Okay, just let us leave this question first. First, let us solve this question. What kind of hazard occurs when we solve this? Okay, so an easy way to find if there is will be hazard or not is to make K-map. How do we find it through K-map? Let me tell you. So I'll just make a K-map. Okay. Yeah. A bar, B bar, A bar, B, A B, A B bar, C bar, D bar, C bar, D, C D, C D bar. Okay. Okay. Let us not write 0 1 3. Not matter. So, but I'll just mention these literals: A bar, C bar, D bar. So A bar is this, C bar is this, C bar, D bar is this. Okay, so there will be one here, one. Other is B, C bar, D bar. B is this, C bar is this, and D bar is this. So one here. One is already here. Next is A bar, C, D bar. A bar, C, D bar. One. Another thing is B, C, D. Okay, this is B, C, this is D. Okay, so let me make this here. We make groups here. Sorry, one group, second group, third group. Okay, I made it incomplete. A, C, bar, D bar. A bar, C bar, D bar. A bar, C bar, D bar. D, C bar, D bar. A bar, C, D. A bar is this, C, D is this. A bar, C, D, and B, C, D. B, C, D. It's fine. Okay. So if we make groups, this is one group, this is another group, this is another group, this is another group. We have four groups. Okay. So how do we check hazard through K-map is, so whenever there are groups which are not situated right beside each other, right? So, okay, let me take an example where there will be, so here in this case there will be no hazard. Why no hazard? That we can see from here, but how to look at it? So I'll need to give an example where we have a hazard. So let's say, let me copy this. So if I had one, the previous thing that I made, one, and one. Okay, so here let's see what we have. Like I have one group. Oh God. One group is this, right? Another group is this, and third group is this. Okay, so I have one quad, one and two pairs. But when how do we look at K-map and tell a hazard occurs? So from K-map, hazard is there if two adjacent groups, let me write adjacent ones, are not in same group. So what does this mean? That this one and this one, they are adjacent, right? They are right next to each other, but they are not in the same group. So this there will be a hazard here. Okay. And which kind of hazard if we see? D plus D bar hazard. Okay. It will be static uh, hazard for D and D bar. Okay. Anyways, so that is not the case anywhere else. These two are in the same group. These these two are in the same group. This has no other common like nearby uh, one. This has no nearby other one. So this these are four are in the same group, but these two are in different group and they are nearby also. So this kind of case, highlight it. This hazard case, but in this example, we see uh, there's no hazard. Why? This one has only one neighboring one, but uh, it is in the same group. This one has two neighboring ones, and both are and it has groups with both this also and this also. Similarly here, this has one neighboring one. It is in the same group. This has one neighboring. It is in the same group. This has two neighboring, and both are in the in groups. Right. So it has no hazard because this situation does not lie. Where we have two ones adjacent to each other but in different groups. So is this condition clear? Yuvarani, it is not static zero. It is no hazard. Okay. So it might be new to you, but please go through the videos uh, in week 3. It will make it very clear. Okay. This was this. Okay. Let us try this question, right? So we have to. Okay. It is. Let me make a K-map here itself. A bar, B bar, A bar, B, A B, A B bar, C bar, D bar, C bar, D, C D, C D bar. 1, 3, 2, 3, 5. You have 1 at 0, 2, 5, 6, 7, 8, 9, and 12, 13, 15. Okay, so now let us make the groups. So you can see one quad is this, you can see another quad is here, you can see one pair is this, also you can see what is one more pair is going to be with this and this, whatever. Let's make it with this. Okay, so now if I look at hazards, okay, so now let us observe all the ones. Okay, so immediately what I can see is this one and this one. They are neighboring. Okay. Yeah, Yuvrani, in this question I hope this will get clear. Okay. So this is a group and this is a group, right? But these two ones are neighboring to each other, right next to each other, but they are in the different groups. So this condition will cause an hazard. So let me write. This will give an hazard, and we don't have any other similar such case. All ones are in the same group anywhere else. Okay. So how do we? So okay, let me just first write what I would have written it as. F would be, if I take this one, so it is A bar, B bar, D bar, right? A bar, B bar, D bar. Then if I take this one, it is A bar, C, D bar, A bar, C, D bar, plus this group, that is B, D, plus this group. So this is what? A, C bar, C bar. Okay, great. So we have found one, two, three, four groups. But now we see there is one this hazard condition. So to remove this hazard condition, what we said, hazard condition is there are two ones which are not in the same group. That is hazard condition. So to remove that, just add them into the same group. So we will make another group here. Let me take some color. So red only. Let me add this one more group. What is plus? What is this? A bar B C. So by adding this A bar B C, I have removed the hazard. Okay. So I've removed the condition where there could be two neighboring ones which are not in the same group. Okay. So anyways, so if we look at it. Okay, sorry, I missed one more, I think. So this and this one, they are neighboring, right? This, its neighbor is this, but they are not in the same group. So another hazard will be here. So to remove that, we should make another group here also. So let us take, I don't know, maybe this color. So I'll make one more group with this and this also. Plus, what is this? B bar, C bar, D bar. Okay. So these two hazards are removed. I'll repeat it. Earlier we had these two ones which are not in the same group, which would cause a hazard, and these two ones which are not in the same group but neighboring. We look from here and here, neighboring, they're neighboring, and which would cause an hazard. So we just added them in the same group and we removed the hazard. So these redundant groups that we had to form to remove the hazard. So our answer should be, I don't know, A C bar B D A B C bar. Okay, so D should be the answer. So uh, is this clear? Like how you identify hazards and how you can remove them? Just to remove them, we see if they are not in the same group, just add them in the same group. That's it. Okay, fine. So let us look at another question that we skipped earlier. Maybe. Yeah. So you can do it in multiple ways. One of the ways could be you can just make K-map. Another way is you just identify the hazards and just add the terms that cause the hazard, right? So let us look at this. I won't use K-map this time. I'll just do it uh, analytically. So let me take a fresh page. So to remove the hazard, I have A plus C bar, B plus C plus CD. This was the same question that I had taken earlier, right? This. So I know that for one static hazard, which we will get when that for a static hazard, we should have C plus C bar case. It would come when A is 0, B is 1, and D is 1, right? So just a second. So okay. So to remove that, we would what we would do? We just add this case, that is A bar BD, to this term. So here this would give me, let me write in different color, A plus C bar, A plus C bar, B plus C plus CD plus A bar BD. This term will remove static one hazard. Write it one, static one hazard. Okay, similarly, so this was first case. Now look at the static zero hazard. Okay, so for static zero, I know that uh, we had seen static zero, we need C bar, right? This will come when A is 0, B is 0, and D is also 0. Okay, so for this, what we can do is, yeah, so static 0, we will need to do a POS form. Okay, so we had this A plus C bar, B plus C plus CD. Then I had added this earlier, bar PD. Okay, to remove static 0, I will multiply this by what? Remove it. Multiply this part by A plus B plus D. Okay, so why I have done this? So in POS form, right? A0, B0, C, D0 is written by A plus B plus D. So I have written this. Why I have done POS? Because I wanted to, because I know this part is giving me this hazard, right? And I had to multiply it with something to remove that hazard. I did not want to multiply it with this part because this was an additional term that I had added to remove static one hazard. So to remove static zero hazard, I had to multiply only this part. My additional term should affect only this part. That is why I had used POS form and multiplied it. Okay. Now, okay, third is dynamic. Dynamic hazard is what? CC bar plus C. Okay, so when we will get this, so we have, okay, so if we have A equal to 0, B equal to 0, and D equal to 1, right? That is what? What is this? A plus B plus D bar, right? So I'll rewrite this. Now, what we are doing, adding a term again in multiplication with this. Right, this not this. A plus B plus D bar. So this will remove my dynamic hazard also. Right. Now if I see these both terms can be combined, right? A plus B plus D bar and A plus B plus D is simply A plus B. That I'll do here. So I'll rewrite that A plus B bracket A plus C bar B plus C plus CD. This is multiplication part plus A bar BD. So this term will remove both static 0 and dynamic hazard. This term removes static 1 hazard. Is it clear? So what we did was just look at the cases and add the corresponding terms to our initial function. Okay, so if there are doubts, please let me know and we'll stop it here. I think we've covered a lot of concepts today, and I'd upload the slides in the video, so please go through them and revise them. But we won't do any more questions today because it will be too much to digest. Okay, so if there are no more questions, we should close for today. Okay, thank you everyone for joining, and I'll see you next week. Yeah, thank you.